Hello everyone and welcome back. Today we will talk about the two flight controls, and they are classified as a secondary flight controls. The first flight control we will talk about is the flap. We will talk about the function of the flap, the location of the flaps, and the type of the flaps. And also we will talk about the leading edge devices, and they are slot and slat. And we will talk about the function of them and the location of them. At the beginning, we will start talking about the flap. The flaps are located on the trailing edge, on the root of the trailing edge. Using of flaps. When properly used, flaps increase the lifting efficiency of the wing and decrease stall speed. This allows the aircraft to fly at reduced speed while maintaining sufficient control and lift for sustained flight. When we see together this figure, we find here the flap and it's located on the trailing edge. When the flap will deploy, the angle of attack, as we see here, it will increases, and here the flap is retracted, so the angle of attack it will not decrease or it will not increase. But here, as the flap deployed, the angle of attack will increase. As angle of attack increases, that help the aircraft while takeoff increase the lift, and during landing will help the aircraft to have more parasite drag, and that help the aircraft to kill speed or to reduce the speed of the aircraft. The flap has 3 or 4 types. The first type is plain, the second one split, the third one slotted, and the last one fowler. In this class we will talk about the slotted and fowler, but when we go to study on the airframe book we will talk about each one. We will talk about the plain, the split, slotted, and fowler individually. The ability to fly slowly is particularly important during the approach and landing phases. For example, an approach with full flap allows the aircraft to fly slowly and at fairly steep descent angle without gaining airspeed. This allows for touchdown at a slower speed. In airplanes, configuration normally refers to the position of the landing gear and flaps. When the gear and flaps are up, an airplane is in a clean configuration. If the gear is fixed rather than retractable, the airplane is considered to be in a clean configuration. When the flaps are in the up position, flaps position affects the chord line and angle of attack for that section of the wing where the flaps are attached. This causes an increase in camber for that section of the wing and greater production of lift and drag. As we talked before, there are several common types of flaps. The plain flap, and this the first type, is attached to the wing by a hinge. When deflected downward, it increases the effective camber and changes the wing chord line. Flaps increase lift and drag. by increasing the wing's effective camber and changing the chord line, which increases the angle of attack. In some cases, flaps also increase the area of the wing. Most flaps, when fully extended, form an angle of 35 to 40 relative to the wing. As we talked before, the types of flap are plain flap, split flap, slotted flap, and Fowler flap. And we take some note about the slotted and Fowler. Slotted flap, in addition to changing the wing's camber and chord line, it also allows a portion of higher pressure air beneath the wing to travel through a slot. The air will go from the beneath of the wing to the slot, and this are characteristics of the slotted type. This increases the velocity of the airflow over the flap and provides additional lift. The last type of flaps, Fowler flap. When extended, it moves rearward as well as down. This rearward motion increases the total wing area as well as the camber and chord line, and this type is used today on commercial aircraft. Leading edge devices. A stall occurs when the angle of attack becomes so great that the energy in the air flowing over the wing can no longer pull air down to the surface. To fix that, we have a slot. The slot is a fixed slot duct air over the top of the wing at high angle of attack. This in the orange color is our slot, and this the leading edge of the wing, and the slot is fixed to the structure. So when the aircraft will goes in stall, the air will go from the downside of the wing to reach the upper side of the wing by the slot. What about the slat? The function of the slat is the same function of the slot, to prevent stall. But the difference in that the slot, as we talked, is fixed, but here the slat is movable. A movable slat moves out of the leading edge of the wing at hinge angle of attack to form a duct for high energy air. How the slat will actuated to the outer side of the leading edge, that what we will talk about on airframe inshallah when we talk about the leading edge devices. On some aircraft, as we have a trailing edge flap, we have a leading edge flaps, and they are electrically or hydraulically actuated and are used in conjunction with the trailing edge flap. That means the leading edge flap will actuated when the trailing edge flap actuated. Kruger flaps are used to effectively increase a wing camber and hence lift. Kruger flaps means the leading edge flap.